I'm from England, right? As you can probably tell. I'm from a small city called Carlisle in England. And I'm from a small district called Harrowby in Carlisle in England. This is one of the pubs.
All right.
Yeah. As you can see, they fought long and hard about the name of the pub in Harrowby. The regulars of this pub, they call themselves the Pirates of the Harrowby Inn. And every time, I really like that. For my money, that's the best pirate pun I have ever heard. And whenever I tell people it, they are underwhelmed. But you are all wrong. That is clever and funny. So, we've come a long way, haven't we, since the 90s, 20 years ago. You'll have some friends over, and it's going great. And then maybe two of your friends would start having a, oh, we do have sound, excellent. Would start having a disagreement about something meaningless, like the release date of Ghostbusters. But then that argument starts to get heated. You know, neither of them are backing down. But it's okay. You hold aloft the answer. For you are the proud owner of Microsoft Cinemania. Don't know why that disappeared. Let's try that again. Whee! That's probably a good sign that we're going to have massive graphical problems during this presentation. That's excellent. We'll see if that continues. But, you know, it's supposed to give you instant access to the history of cinema. But, of course, it's not truly instant, is it? Because first, you must go to the room with the computer in. And then you turn it on, and clunk, all the fans start whirring. You get the static buzz as the CRT monitor whirs into action. Windows 3.1 slowly boots up. And then eventually, you get your desktop. But then it does this. And that really sets your expectations, doesn't it? Because we are in an era where booting up successfully is a fanfare-worthy moment. But by the power of multimedia, you reveal authoritatively that Ghostbusters came out in 1984, and you did that in under 10 minutes. The dinner party is saved. The web really changed everything. With the web, you get the information instantly. No installation is needed. Native apps such as Cinemania and Encarta, they looked out of date really, really quickly. Having a separate app for these things just became weird. The stuff on the internet was better. It was built with this new, interconnected, modern world in mind. The browser runtime started to replace more apps. Email clients, one of the first. But then things like office tooling, video players, code editors even. Native apps became the exception. If you look on the Amazon top-selling laptops list, you'll see Chromebooks there. And that's how secondary native apps are. Although that's not true, is it, on mobile? Their native apps rule. And because they build to the strengths of the platform. And a lot of the web predates that. Some of the web is even hostile to mobile. Here's a creative agency that I will not name. But this is what you get when you visit their site on a phone. Choosing your creative agency isn't like buying a pair of shoes. So why don't you make yourself comfy and visit our site on a real screen? But they're right. No, they're right. Choosing a creative agency is not like buying a pair of shoes, because I have never had a shoe tell me to fuck off and come back when I have real feet. If you visit their desktop site, obviously, you get a much better experience. You see the sites they've done. They list the things they're expert in, which, of course, includes responsive sites. This is hostile to the whole mobile platform. The more worrying case is sites that are simply hostile to the mobile web. This is a horrible situation, right? The user has gone to these sites in a browser, potentially following a deep link, and rather than sending them the thing they want, we send them somewhere else, where they can download a thing and install that thing, which they can run, which may contain the thing they originally wanted, somewhere deep within the UI. Every day. Well, no one's saying that's a good experience, right? No one's saying that's good, but it's one that many developers think is worth it to get the users off the web and into a native platform. And why is that? Well, have a think about the native apps that you use day to day. Those are the places that the web has failed. But what caused that failure? What features do those apps have that you use that make them impossible to replicate on the web. For me, it's these apps, really. I use these often, or I rely on them in some way, and they can't be done on the web because of things like a lack of push notifications. This is vital for these apps in yellow. They tell me someone sent me something, even when the app's closed, or something happened. I rarely open trip it, very rarely, but I forget it's there. But then occasionally it'll send me a message saying, your flight's been delayed, or your flight's been cancelled, so it's really, really useful to me. Background sync, of course, the app's in yellow again. They send and receive stuff when the app isn't open, from downloading podcasts to sending that email later when I have a better connection, which takes us to the offline stuff. I depend on this for more apps than I realize, way more. From playing music to checking where my hotel is, to looking up a meeting location. I don't want to depend on connectivity for those things. And of course, we need better performance and better operating system integration, app menu icons, battery stats, payment and account integration. Everything that makes it first class on the platform. The web can't do these things, and that's a bug. But what gives me optimism is it's bugs that we are fixing. We are actively landing code to fix these things. These are the ones I want to talk about today. These require something new. Background sync happens in the background. Push notifications are received and dealt with in the background. Offline isn't in the background, but it requires something to run sooner than the page appears, so it can handle network connections and version control and things. And that thing is the ServiceWorker. This is the spec. This moment got a round of applause at Google I/O. Don't patronize me. Fair enough. I admit I could have dressed this up a little bit. I really like what graphics cards do in this scenario because they're essentially just a circuit board. They don't do anything on their own, but they want to sell themselves to gamers as the thing they absolutely must have. So the boxes they come in are amazing. They're filled with this kind of sub-deviant art, shite artwork. You get the usual terrible sexist stuff that you get with anything to do with games, it seems, at the moment. But also things like the hideous offspring of Yoda and Shrek I found in one box. And, of course, Teenage Mutant Ninja Dog appears on one of them as well. So in that vein, I present to you the ServiceWorker. That's Mum-Ra the Ever-Living, using his powers of evil to control browser features. What badge? I thought about doing that, but I really couldn't be bothered. I'm sorry. Look, you've got the skull and crossbones on some slides, right? I did that in the airport. I'm so jet-lagged. Okay, yeah, if someone wants to design us a better logo, please do. But this is a feature that's being worked on between Google, Mozilla, Samsung, and other third parties. It's like a shared worker, in that it's shared between many apps, and it has many pages even, and it has no DOM access. Unlike a shared worker, it can exist without any pages. And it's shut down when it isn't in use, keeping the memory footprint small. It gives us this background JavaScript context to do all of this stuff. This is still in development, so if you want to play with ServiceWorker today, you'll need to use Chrome Canary or Firefox Nightly. And in Chrome, you'll need to go to About Flags and enable experimental web platform features. And once you've done that, you'll need to give the browser a restart. If Chrome isn't your thing, then use Firefox Nightly. Just go to About Config, and you'll need to enable dom.serviceworkers.enabled. Once again, give the browser a restart. I'm going to stick to Canary for the demos because we're here in a Google office, so it would be rude not to, really. But also the debugging tools there are further ahead. Firefox are going to they're going to catch up very, very soon, but not quite at the moment. So if you want to know what's supported and where, this site has the answers. Is ServiceWorker ready? It'll tell you the status of all of the various sub-features of ServiceWorker across the browsers. So let's take a look at the offline stuff, because it's the foundation for the other features. Offline suffers from the same misconceptions as progressive enhancement. People say, I don't need my app to work offline because my users have permanent internet connectivity. But it's not just about dealing with zero connectivity. It's about treating the network as an enhancement. It's like, Ilya covered some of this stuff before, but when the user enters a URL or navigates to your site, it creates a new document, but we have to get data for that. So off we go to the network. And this can take a long time, just to get the HTML. And once we've got that, we can't render. We need to send off requests for all of the sub-resources, the CSS, the JavaScript, the images. And as these come back, we can start to render, but not completely, because these start other sub-resources, XHR, fonts, images used by the CSS. And then we can get to a complete render. That can take a really long time. As a practical example, we're going to take this sort of demo app called Train to Frill, a simple responsive site that displays the latest train photos from Flickr. Don't ask me why trains. I was on a train when I started building this, and I had a moment of complete zero inspiration, but it's going to be trains. Let's load it on a phone. Now, we're going to load it with a simulated edge connection, and that's 250 kilobits. So not the best connection in the world, but 15-year-old me would have killed you for that kind of connectivity. It's by no means the worst that you would get on a phone today. So let's load it. 3, 2, 1, go. There we go. We get first render after over a second. That wasn't JavaScript dependent. We get some content after 5 seconds, and then begins the long wait. These images are 200K each. As Ilya was saying, if you're dealing with a device of this density, images are big, and this is what Flickr would give me if I wanted enough pixels to cater for a device like this. Well, we get our first image after over 30 seconds, and eventually, after what seems like an age, we'll get the final image through at the top there, and there it goes. I had to cut that video down. That's not real time. It just takes so long. Those figures are the real figures. Of course, we could probably compress those images a bit better, and we could do something to ensure that the top images load a bit sooner. I just took what Flickr gave me. But we are still winning compared to native at this point, because the equivalent for the native app is the trip to the App Store, the download, the install. It's a slow and comparatively poor user experience. But native kicks our ass on the second visit, because it used that initial download to cache a load of stuff and set a load of things up. We have the browser cache, right? But the whole web is fighting for that cache, and something pointless can override something really useful. And we deploy stuff really regularly, so we make one change to our CSS, and now we have to change the file name of the CSS, so we've invalidated the cache. But this page does something different. It registers for a service worker, allowing it to do something about that second load. This registration happens just with a single line of JavaScript like that, giving the location for the script. You can also scope it to an area of your origin, which is useful if you have one origin with many apps, such as GitHub Pages. The default is the whole origin, which we'll use here. Registering is an async operation, so it returns a promise. So you get callbacks depending on whether it succeeded or not. You can only register for service workers on pages served securely, HTTPS. Service worker gives you so much control that we cannot afford to let that lie in the hands of a man in the middle. GitHub Pages serve over HTTPS, great place to put demos, and localhost is exempt for development purposes. As for this worker script, we're just going to put in a console log. We're also going to listen for the install event, and that's called when the service worker sees this worker for the first time. So let's see that in action. First, I'm going to go to service worker internals, which is where our debugging stuff is living at the moment. It will move into DevTools, but it's early days. These are all the service workers that the browser is aware of. As you can see, it's aware of none. So let's open the train site, and we'll open DevTools there as well. As you can see down here, we've had a successful, we've got a smiley face, successful service worker registration. If we go to service worker internals now, there it is, and there's our console messages. But even better, we can open an actual DevTools window for that worker. We can run stuff on the console. We can set breakpoints. We can inspect things in detail. If we fast forward time a bit, this worker will terminate. That's not a bug. It closes when it's not being used, and that's just to save memory. And at this point, congratulations. You are now wielding the power of the service worker. But what did it actually get us? Nothing. Nothing at all. But wait. That's actually a good thing. Trust me, it's great that it does nothing. Compare this to AppCache. If we give like a page, an HTML page, a manifest, and that manifest contains nothing except the words cache manifest, which is required to make it valid, yeah, sure, I'd expect my page to go from this to this, said no one in the world ever. AppCache missed the point of the extensible web completely, almost as much as Disney did with Jake and the Neverland Pirates. A good pirate never takes another person's property. Shit, pirate. Anyway, we didn't want to repeat AppCache's mistakes. So Service Worker doesn't do anything unless you tell it to do something. AppCache broke a load of eggs and failed to make an omelet, but it is made of the right ingredients. There's routing, we've got fetching, caching, updating, and version control. But in order to get them, you must traverse the piles of implicit behavior, which are, of course, guarded by the army of robot wasps. If you've used AppCache before, you'll know exactly what I'm on about. So we got rid of all that. We cleared it away. We separated them out. And we give you the separate parts to use however you want without getting stung. This is the extensible web. Don't let the platform give you a fish, say, hey, I want the fishing rod, and show me how to use it. But give me the fish as well. This is what we want from the platform. We want high-level and low-level APIs. So first up, routing, putting you in control of requests. The service worker is event-driven. We've already seen install, but there's also fetch. And this is fine for any navigation request to your scope, but also any sub-resource requested by those pages. So in ServiceWorker internals, I'm going to start up this ServiceWorker and inspect it. And now I'm going to navigate. You can see we've got this fetch event here with the debugger statement. And now I'm going to navigate to the page. And as soon as we do that, we hit this debug point for the root page. And if we fast forward a bit, I skip past that, we'll get another request, this time for the CSS. And then we get one for the logo, and then one for the JavaScript. And then we get one for the request to Flickr's API. This is to another origin, but we still get an event for it. And then we'll start getting the requests for the images through. And we don't just get the URL either. You can get detailed information about the request, such as the headers, the mode, the referrer, as much as we can safely give you in terms of security. But hey, the cool bit is, it's like other events, such as click, touch start, and key down. You can prevent the default and do something else. You can respond with something else. Responses can be created manually. So there, I'm just creating a new response. Sorry, no trains today. Yeah. Which changes the response from this to this. But the interesting thing there is we delivered that without going to the network at all, making it the first offline demo of the talk, only halfway in. But we can do better than that. When the browser discovers this service worker for the first time, we'll get it to make loads of requests to the network and get loads of responses back. This may be fast, it may be slow. The network is unpredictable. We don't care, because the user already has the page. We're not disrupting them. If all the responses come back successfully, we'll throw them into the cache. This pre-caching pattern is good for stuff that a native equivalent would make part of the initial download, but we get to do it in the background without disrupting the user. For our train site, this is like the root page template, the CSS, the JavaScript, the design images, all the static stuff. And then in future, when we get a request for one of these things, if it's in the cache, we'll just get it from the cache and send it on. The uncertainty of the network is no longer our problem. And this is really simple, thanks to the caching API that comes with ServiceWorker, giving you full programmatic control over the cache. So in terms of our train site, in the install event that we had before, we're going to call event.waitUntil. And this lets you pass in a promise, allowing you to extend the installation process or indicate its failure. So here we're just going to create a cache, give it a name. That gives us a cache object. And we're going to add a load of stuff to it, all of our static assets. This is an atomic operation. If any of these fail, the whole thing fails. It fails the installation, and this service worker won't control pages. But that means if install succeeds, then we have these files. We can rely on having them as a dependency. Here to tell us a little bit more about Chrome's implementation of the Cache API, we're going to go live to Senator Vreenak of the Romulan Empire. Senator, how's it looking?
It's a fake.
Yes, thank you very much, Senator. Tell the kids I said hi. The API that's in Canary at the moment is a complete fake. It doesn't really work at all yet. It's not usable. But thankfully, there is a polyfill backed by IndexedDB. The proper implementation will arrive in a few weeks. But how do we use these cached items? So we can call caches.match as part of a respond call, and we can pass in a request. And that will look in the caches for the response that matches the request. And matching is done very similar to how it works in a normal browser cache, things like method, URL, vary headers. If there's no match, you'll get null back, which is going to start breaking things. But promises let you recover from that. So we can do .then, and if response is falsy, I can do something else. What could we do instead? We could return something else from the cache, like a fallback page. But what if we wanted to try the network? To do this, we need to be able to make a request using JavaScript. So back in the 90s, in 1999 to be exact, Microsoft engineers were working on an exciting new API, but they didn't know what to call it. It contained some initialisms, some acronyms. And they couldn't decide if they should be all caps, like the HTML and inner HTML, or just the first letter, like getElementById. So they did both. An XML HTTP request was born. Other than that, the name is perfect. XML, because it only deals with XML, except it doesn't. HTTP, because it's restricted to HTTP, except it isn't. And request, because you get a request object back, except you don't. We've tried to modernize this API a bit so it makes more sense, but it's still pretty bad. Fetching some JSON is still absolutely terrible. We've been patching this API up for 15 years. I do not want to be using this API when it is old enough to drink. Thankfully, the fetch spec by Arnav van Kesteren of Mozilla gives us lower-level control over requests and responses. We've already seen some parts of it, the request object, the response object, they're part of this. Lower-level APIs tend to be more complicated and harder to use, but XHR is so bad that is not true here. The equivalent to this in the fetch spec, fetch URL, gives you a promise, parse it in a format you want, gives you a promise, and you're done. This is a forward-thinking API as well, so ES6 arrow functions make it a lot neater. ES7 async functions, you can turn it into a one-liner if you want. It's a bit messy, but it is possible. So to answer the question, how do we send this request to the network? Fetch it. So where does that get us? So in comparison to before, 3, 2, 1, go. We render almost instantly. We get some data in after 2 seconds. That's still coming from the network, but our JavaScript arrived so much quicker that we were able to make the request sooner. Still a sad story with the images, though. But we got to first render really quickly. All of that stuff Ilya was talking about, all of that DNS and network crap, we didn't have to worry about it. We got to first render without all of that. But with these images, let's fix those. When there's a request for a Flickr image, that goes to the service worker, as all requests do. And if we've got it in a cache, we'll just return it. Otherwise, off we go to the network, the long round trip. And once we get a response back, we'll send it to 2 places. We'll send it to the cache and the page at the same time. So next time it's requested, we can get it straight from the cache. We're doing this with Flickr images. It's also good for avatars and things, that kind of pattern. In terms of code, we do this by special casing URLs ending in staticflickr.com. And that's where the Flickr images live. And in that case, we're going to get it from the cache if it's there. Otherwise, we do a fetch, add it to our cache, and send it back to the browser. We need to be careful with this pattern, though, because we're adding to the cache with every request for a Flickr image. So we'll need to garden that cache at some point. We'll pick that up later. But for now, how does that actually improve things? 3, 2, 1, go. Instant render as before. We get content after a couple of seconds. But this time, we've got some images. All of the images we've already seen, not this top one, we haven't seen that one before. That arrives in about 11 seconds. This is pretty good, but we're still dependent on the network for that API call to Flickr, the one that tells us which images to display. Let's fix that. This one's a little bit different. The page makes a fetch request, which goes via the service worker, as all requests do. But at the same time, the page also goes straight to the cache, because pages can access the cache as well. If it finds a response, it'll take it, it will render using that result, and that will be old data, and that will trigger the download of all the images, but they're in the cache as well. We'll get to our first view really quickly. Meanwhile, the service worker sends the request to the network, gets it back, and does what we did with the Flickr images. It sends it to the page and the cache at the same time. This is also a good point for us to clean up the image cache. With this pattern, the page makes 2 requests and renders content twice, one from the cache and another from the network. This means we get to render fast with old content, but provide up-to-date content when we get it, if we get it, which we wouldn't if the user's offline. The best native apps do this. Not many, but the best ones do. So here's where we're at. We're special casing static Flickr. We also want to special case api.flickr.com. In that case, we do this. I'm not going to go through it line by line. At the top there, we're fetching and putting in the cache. At the bottom, we're returning to the browser. This gnarly bit in the middle is where I'm going through the caches, finding out which images we don't need anymore by the response we've got from Flickr, and deleting those. Even with promises, this is a bit ugly, but thankfully ES7 async functions make it really small. And that's the service worker sorted. This pattern requires the page to make 2 requests, though. So over on that side, we make 2 requests, one to the cache and one to the network, and we race them. Because it is possible for the network to beat the cache. We see this a lot on Windows machines with virus scanners installed. Well, probably, you buy a PC these days, it comes with 8 virus scanners installed, and that basically just wrecks disk access times. So the network can be faster a lot of the time. If the cache succeeds and then the network succeeds, we just swap in the data. If the cache succeeds but then the network fails, we silently fail at that point. That's a good offline experience. This is what apps like Twitter do. That's probably too much code to show on slides, I understand that, but my point is we're expressing relatively complex, async, custom behaviors in relatively small amounts of code, even using the low-level primitives. And the effect of that? Well, let's remind ourselves where we started. On the first visit, without a service worker, it took us ages to get to first render and ages to get any content. There it goes. And then the images just took far too long, over a minute for all of them. But with a service worker and the code that I've showed in the slides and the caching, 3, 2, 1, go. And it's an instant render with content. New content comes in a little bit later, and that image will come through in a few seconds. But we've shaved a second off first render. We've shaved over 30 seconds for some images. This is the kind of stuff that Ilya would kill for to be able to do that on the network, right? But we can do it without the network. And you get those kind of response times, whether you're on a fast connection, a slow connection, or no connection. This is what catches us up with native startup performance, and it gives us the foundation for these other things, like push notifications and background sync. These haven't arrived in Canary yet, but they're coming soon. I guess I'm slightly running out of time, but I'm going to, before we look at the code for push, I'm going to try and do a live demo, and we'll see how that works. So, OK, I'm going to do the wolf thing. I'm going to press 3. Yay, that worked first time. Excellent. OK, so what I'm going to show here is a build of Chrome that we have internally. So there we go. This is Chromium. So this is just a simple chat application, and we'll see if this works, if the demo gods are shining upon me. So I'm going to type in hello, SFHTML5. So see if that arrives on the phone. Come on. Yes, there we go. OK. That's nothing special, right? WebSockets, we've been able to do that for ages. So, but what I'm going to do now is I'm going to close the app. So that's it. There's no apps running at all on this phone. The browser is not running. But I'm going to send another message. And what happens this time is just using open web standards, and there is actually a spec for this, we've received a push notification, a native push notification. And because it's native, it has also appeared on my watch. There it is as well. Just using the open web entirely. As I say, this isn't a custom build at the moment, but we're hoping to ship this stuff in Canary very, very soon. Let's see if we can get back to these slides. So the code for that is pretty simple. So on your page, you register for push. You get some registration details, which will give you the details for GCM, for Chrome, the cloud messaging stuff. Firefox will have their own thing. Apple have their own thing. And then you'll send that up to your server once you've got it. And that gives you the means to send messages to that user later, even if their browser's closed and the site's closed. They will have to grant permission for this. We're not going to give you this for free. They'll get some kind of notification saying, are you happy with the site doing background stuff? But then when the user receives a push message, over in the ServiceWorker, you get an event for it. You can look at the data that you get. In our case, we'll update some caches and then show a notification. But you can do what you want. You also get an event when the notification is clicked. Once again, you can do what you want at this point, but it's likely that you're going to open a URL. You can also focus an existing tab as well. I'm running out of time, so I'm going to skip through some of the background sync stuff, but it's very similar to the push messaging stuff. Like if sending an email fails, save that data into a database, register for a background sync saying, hey, sometime in the future, give me a chance to do something else. And in your service worker, you'll get an event, a sync event, look at the ID, and do what you want, which is usually going to be send those emails that failed to send. You can also, this is registering for a single sync event, which is kind of like, I was unable to do some stuff due to connectivity, let me do it later when the user has connectivity. But you can also request an interval sync as well. An interval you specify as a minimum. Syncs will actually happen heuristically depending on how often the user uses the site. And we'll try and coalesce with other events to save battery. With ServiceWorker, we gain a lot of the features that make native superior, but we retain the bits that make the web superior. Instant on, no install required, open platform. Chrome is going to start shipping this stuff to stable this year, the offline stuff especially, and then next year for some of the push and background sync stuff. Firefox are actively developing it as well. Microsoft are investigating it. We haven't heard anything from Apple, but that's not unusual at this point. Thankfully, it's designed to be used as an enhancement. It won't disrupt the browsers that don't support it. As long as you use basic object detection, as soon as this hits the millions of users that have Chrome, you can start giving them that benefit. ServiceWorker doesn't make stuff work offline. It doesn't turn push messages into cache updates and notifications. It gives you nothing for free, but it treats you like an adult. It gives you the moving parts and says, do what you want with them. Use it to make things faster, make things work offline. Use it to transcode a video format the browser doesn't support natively. Build a client-side wiki. We've seen that already. Do what you want. Do it in a way that's unique to your app, the way that gives the best user experience. I am heavily biased because I've been involved in the design of this stuff, but I think this changes the scope of what the web is capable of more than any feature since XHR. Let's build some cool stuff with it. Thank you very much.
All right, thank you, Jake.